All right. Bye, Ben. I wanted to work on gas laws practice problems. And I want to say right now that your copy on numbers 2, 4, and 5 may have a different number of significant digits than mine does. It'll still be worked the same, so you should be able to figure out what's going on. You'll just have different significant digits. Now up here it says to remember that there are going to be some converting going on. Standard temperature and pressure is 273 Kelvin and 1 atmosphere pressure. And 1 atmosphere can be expressed as this many millimeters of mercury, or that many psi's, or that many kilopascals, or that many torr. There's just a lot of different ways to talk about pressure. I do not expect you to memorize any of those conversions. I would definitely be glad to give them to you. So if I look at number 1, it says the maximum safe pressure that a certain 4-liter vessel can hold is 3.5 atmospheres. If the vessel contains 0.410 moles of gas, what is the maximum temperature to which the vessel can be subjected? So I know my N is 0.410. I know that my volume is 4.00. I know that my pressure is 3.50 atmospheres. So it looks like to me I'm going to use the ideal gas law. PV is equal to nRT. The big clue was the N. So they're asking me for the temperature, so I'm going to say, well, 3.50 atmospheres times the volume of 4 is equal to 0.410 moles. R is a gas constant, 0.0821 liter atmospheres over mole Kelvin. So my temperature is going to come out in Kelvin, and when I solved it with the calculator, I got a temperature of 416 Kelvin. And I had 3 figures in my answer because if you look back at the problem, there are 3 there, 3 there, and 3 significant digits there. A sample of gas has a volume of 3 liters, so V is 3 liters. And that's my first volume. My first temperature is 303 Kelvin. And my volume 2 is 1.25 liters. And my temperature 2 is, I don't know. So I'm going to say V1 over T1, and this is Charles's law, is equal to V2 over T2. I'm going to come over here and say that I had 3.00 liters over 303 Kelvin is equal to T2 over, let me do that right, 1.25 liters over T2.